So graphing exponential functions. There's a couple things, and I think this is already at the top of your paper. When you're graphing, who remembers AH and K? AH and K, so that's back. The K value can be written in the back or it could be in the front. So you always have a horizontal asymptote. We don't have a vertical and a horizontal, just a horizontal one at y equals K. The domain is all real numbers. And the range is either going to be K to infinity or negative infinity to K. So this is, if A is positive, this is what it's going to be. But if it's reflected and A is negative, then this is what it's going to look like. So I usually do a two-step process. And the first thing I do is I make my parent table just using the base. And then I create a second table where I apply the transformations. What are you talking about? Oh my goodness. Then I make a second table where I apply the transformations and then I graph it. So you're always going to add the h to x and then you multiply y by a and add k. That's how you're going to apply your transformations. So h changes your domain and and a and k will change your range. All right, so now that we got that, let's get started. Let's look at number 1, which is just a basic. Is this, first of all, is this your example 1? Yes.
Go back to the first.
Right here.
No. Where do you put horizontal axis? So add that one. You just write down one.
I don't even know. What does the numbers look like? Oh, you just have to fill it in? Oh, yeah, the horizontal asymptote is y equals k, and then you fill in your domain, and you fill in your range.
Yeah, I was just listening.
Okay, we got it. We good?
So what's the domain?
So the domain, h, so down here, we always add the h to x, and then we take the y, multiply it by a, and add k. And I think I put that on there. H. Because if anything you add to x, because x is your domain, so if I'm adding h to x, then that's going to change my domain.
Okay, I'm not talking.
All right, is this what your number 1 looks like?
Yeah.
All right, so what is the base of my exponent? 2. So I'm going to make 2 tables. So my first table I'm going to make is just y equals 2 to the power of x. And we can choose our x values. 2 is the smallest base that we can go. So I'm just going to use -1, 0, 1, 2, and 3. You can choose, because remember, your domain is all real numbers. You could pick any numbers you want to use. Okay, I'm just choosing -1, 0, 1, 2, and 3. Now, if you need to, hopefully you don't, but if you do, go ahead and use your calculators to find your 5 y values. So 2 to the power of -1. Does anybody know what that is? 1/2. So that would be 0.5. Anything to the power of 0 is what? Not 0. 1. So 2 to the power of 0 is 1. What's 2 to the first power? 2. What's 2 squared? 2 times 2. And what's 2 times 2 times 2? 8. So we have our base. This is our base parent table. Okay, so when I'm looking here, the a value is the number in front. There's an invisible 1 right here. So in this example, a is 1. H can be found in the exponent, and you always flip the sign. So notice how it says x minus 3. That means that h would be positive 3. And your k value, there's an invisible plus 0 out here. So k is 0. So there's only one transformation that we need to make. And that one transformation is from h. So what did I say? What do you do with the h? What did it tell us to do? How do we apply the h transformation? What do we add it to? X. So we just need to, we're only changing this side. We're going to add 3 to these numbers. That's the only thing that's going to change.
How do you get A equals 1 again?
It's the number in front of the base. If you don't see a number, it's 1. Just like x, what's the number in front of x? 1. So if you don't see a number, then that means A is 1. So it would be like 3 times 2 to the power of x minus 3. Okay, that's a good. These are all good questions because theoretically, I mean, we're gonna be finished with graphing on Monday, and you get a test in a week. So, okay, so let's go ahead and do that. So I'm just going to make my second table. My y values don't change, so I'm going to keep those the same. Go ahead and add 3. I'm adding 3 to these 5 numbers. So I got 3 plus negative 1, or 3 minus 1. 3 minus 1 is 2. 3 plus 0 is
3.
3 plus 1 is 4. 3 plus 2 is
5.
and 3 plus 3 is 6. All right, so this is what we're going to graph. Now, before we start graphing, what did I say your domain is going to be for every single exponential function? All real numbers. So let's go ahead and write that in. You're also going to have a horizontal asymptote at y equals k. And remember, in this example, k is 0. So that would be y equals 0. So I'm actually going to draw that in. So our x-axis is our asymptote. So if you have a highlighter, you can kind of highlight it. So now let's go ahead and graph these points. So we're going to graph a point. Go ahead and freeze the screen. So I'm going to graph a point at 2.5. So 2.5, so that's right above my asymptote. And then I have one at 3.1. And then at 4.2. And then 5 up 4. And then 6 up 8.
So with your range?
I didn't fill that in yet. So we're going to come down. It gets really close, but it never crosses or touches the asymptote.
If it crosses, it's bad, right?
Right. Just like with rationals. But we only have one asymptote now. Now our range, what do you think our range is going to be? 0 to infinity. Because this graph does not go below y equals 0. It never even touches y equals 0. So when you write your range, you have to use parentheses. It will never equal 0. It'll get really close to 0, but it won't equal 0. It'll be 0.000008, but it'll never actually be 0. That's why we're using parentheses. And then how do you find your y-intercept? What's the definition of y-intercept? Y-intercept is the y value when what?
X is 0.
X is 0. So let's go ahead, use your calculator to find your y-intercept. And you just substitute it in. So it'll just be y equals 2 to the power of 0 minus 3. Which should give you 1/8. But go ahead and check it in. You can put it in your calculators. You can also write it as a decimal. But I know that 2 to the power of 3 is 8. So that means that 2 to the power of negative 3 will be 1/8. And that's our first graph. Any questions?
We never got the parent function.
Nope. And you don't even have to make the parent table if you don't want to. I always make them both, but that's because that's how my brain works. Yes, Daniel.
The X value in the range, so horizontal asymptote.
The X value is the domain, and the Y values are your range. Did I say that right? The X value is your domain and the Y value. Okay, yeah. It didn't sound right, but it was right. All right, let's do another one. All right, so now we have an A value. So, Elijah, you were asking me what it would look like. This is what it's going to look like. The A value is the number in front of the base. So, A is what? 1/2. H is always inside of your exponent. It's in the exponent, but you flip the sign. So instead of a +2, it would be a -2. The K value is -7. So now my base is 3. So again, I'm making this table. I'm not going to graph it, but I'm making a table for y equals 3 to the power of x. Now 3 is a bigger base. So I can't go all the way up to 3 because our graph paper, if I do 3 to the power of 3, that's 27. So I'm only going to really graph 4 points because the highest I can go is 3 squared before I'm off my grid. So let's go ahead and figure out our y values for our parent. So I got 3 to the power of -1, which is 1/3. I'm going to write that as a decimal because we usually like decimals better. Then 3 to the power of 0. Anything to the power of 0 is 1. And then 3 to the first, 3. And then 3 squared, 9. So now I'm going to make my second table where I apply my transformations. I'm going to add the -2 to my x values. And then with my y values, I'm going to multiply them by 0.5 or 1/2. And I'm going to subtract the 7. So go ahead and do that to both sides. Create your table. And this is the table that we will actually graph. So use your calculators to get your new table. So you're going to add -2 to your 4x values. And then you're going to multiply by 0.5 and subtract 7 for your 4y values. So I'll give you a minute to do that. I don't know why I got 2 calculators. You need a calculator? It's crunchy.
Yeah, it's like.
I don't know. Calculators are hard to come by these days.
So when you actually draw back in for the y-intercept, do you include the 1/2 too?
Yes, the entire equation. And I think for this one, we don't even have to because see how 0 is going to be one of our numbers? So we look at our domain, we're going to get our y-intercept at the end because we'll have 0 is part of our numbers. So we don't even have to do that part. It just wasn't in the first example. Okay, make sure you agree with my numbers. Who had those? That is their table. All right, so we got a lot of fractions because A is a fraction, yeah. So I'm going to fill in.
Did you round to 6.85?
Nope, that's what I got. Did I do that wrong? You got negative 6.85?
Yeah, I got 6.83, but does it really matter?
No, it doesn't really. Okay, so let's go ahead and graph it. Our domain is all real numbers. That never changes. Our range is going to be from k to infinity, which in this example is -7 to infinity. Our horizontal asymptote is going to be at y equals -7. And we actually have our y-intercept, so I can fill that in this time because that was a part of our table. So let's go ahead and graph it out. I'm going to draw in my horizontal asymptote first, just so that I remember not to cross this line. And then I'm going to do the best I can as decimals to graph our points. It should look like the general shape of an exponential though. So it's about here. And then we just get closer and closer. So as I'm coming in, I'm like right above it. And then I cross through. And then it's going to go up. Like exponentials increase really fast. And that is the graph. It's not. I agree. We'll do a couple more and then we will end for today. Oh, there's only 2 more. Wow. So we'll do 2 more and then we'll be finished. Yes. So did you take 9 times 0.5 and put 9 times 0.5 and then subtract 7? Did you get it? Okay. All right, 2 more and then we're finished. Let's go. So this time, what would be my A value? 1. H. What's H? 0. What's K? 1. I'm using, because the base is 3, I'm going to use the same table. So I'm just going to rewrite this exact same table for my parent table. So my y equals 3 to the power of x. All right. And we're only making one change. And that's adding 1. Because h is 0, so adding 0, that doesn't change anything. So my x values are going to stay the same. And then for my y values, I'm multiplying it by 1, which doesn't change anything. But I'm also adding 1, which will change it. So let's make our table. So again, my left side doesn't change. I'm only adding 1, which is pretty easy to do without a calculator. 1 plus 1 is 2. 3 plus 1 is 4. 9 plus 1 is 10. Let's fill in what we know. And we got our y-intercept again, so we can fill this in. We don't have to actually take the time to do it because we got lucky. It was in our points. So let's go ahead and put that here. And we know our domain. We have a horizontal asymptote where? What's my k value?
1.
So we have a horizontal asymptote at y equals 1. I'm going to go ahead and draw that in. And then plot my points and we're done. And what do you think our range is going to be for this one?
1 and infinity.
1 to infinity. Yeah, so let's go back to the top of the page. Here, I think you have a little box where it says y times. You always add the h to x. You're multiplying. You multiply y by a, and then you add k. I think it's in the box off to the side of your paper where it says ya plus k. You always multiply y by a and then add k. And that's for any function. It doesn't matter what it is. Like we're going to do logarithmics next. Same thing. All right, last one. What's our a value? A is a negative 1.
What was the range for the last one? Oh, it's from 1 to infinity, right?
Yes.
So it's from your horizontal slope.
Exactly, yep. So again, if you look at that first page or at the top, your range is either going to be k to infinity or negative infinity to k. That's it. So definitely you want to study what you see at the top of that page. Okay, last one. So notice that it just had a negative sign. The 1 is invisible, but that negative is your a value. The base is always a positive number. We cannot have a base that's negative. So my base is 2. A is negative 1. What is k? What is h? Sorry. What's in the exponent?
-1.
0. And what's k? 8. So my base is 2. So we're using the same table that we used for example 1. I'll go ahead and write it again. For a base of 2, I can get 5 points. Okay, so again, you add the h to x. H is 0. So I'm adding 0, which means that this column won't change. But your y value, we're going to multiply it by a and then add k. So I have to take these 5 numbers, multiply it by -1, and then add 8. So go ahead and do that. Create your table. Yep, it's in there. Yep, it'll be this point. So I'm not using a calculator, but I think for the first one you get a positive 7.5. And then -1 plus 8 would be a positive 7. -2 plus 8 is 6. -4 plus 8 is 4. -8 plus 8 is 0. Make sure that's right because I'm never confident. Who got those 5 points? Okay, good. So we'll fill in the range last, but our domain, we should know. That doesn't change. That's all real numbers. We also have a horizontal asymptote at y equals what? 8. And we know our y-intercept will be at 0, 7. So let's go ahead and graph it, and then we'll do our range last. So I'm going to draw in my horizontal asymptote. And then we have our point at negative 1, 7.5. So that's right under it. And then we're at 0, 7. And then we're at 1, 6. And then we're at 2, 4. And then we're at 3, 0. So this graph is upside down. It's really, really close to 8. And then now, this graph has an arrow pointing down, not up. Oh, that was kind of ugly. Do that better. This is what the graph looks like. So you see how it's reflected down? Because it's reflected down, your y values are coming from negative infinity. And then it's going up towards the 8. So my range won't be 8 to infinity. It's going to be what? Negative infinity to 8. All right, we're going to end there. You can start homework 18, and then Monday we probably will we'll definitely finish by Tuesday. I'll pass out the study guide Tuesday, and then you will have a couple days to review and take a quiz.